All right, so we've used substitution. Now we're going to learn the other way to solve our system of linear equations with algebra, and that would be elimination. So we're going to recap by just remembering what substitution is here. Substitution, remember we solve for one variable and sub it into the other. So I'm going to solve for y here because y doesn't have a coefficient. It looks like it'll be easy to get by itself. So I'm going to subtract 4x from both sides. And I get that y is equal to 5 minus 4x. Subbing into our first equation here, 2x minus 4 times y, and y is 5 minus 4x. That equals 7. So remove our brackets. So we're going to distribute our negative 4 throughout. We get 2x minus 20 plus 16x equals 7. 2x and 16x equals 18x, and I'm going to move my 20 to the other side by adding 20, so that equals 27. Divide both sides by 18, and we get that x equals, reducing this fraction by dividing both the top and the bottom by 9, I get 3 over 2. All right, now that we've solved for x, let's sub into our first equation to solve for y. So 2 times x, which is 3 over 2, minus 4y equals 7. I get 3 minus 4y equals 7. And I'm going to subtract 3 from both sides. I get that negative 4y equals 4. Divide both sides by negative 4. Y equals negative 1. Check our work by subbing into our second equation. So 4 times x is 3 over 2, plus y, which was negative 1, equals 5. 4 times 3 is 12, divided by 2 is 6, minus 1 equals 5, 5 equals 5. We've done this correctly. Whew, that's a weird 5. Okay, so multiplying or dividing each equation in a linear system by a non-zero number does not change the solution. So this is where we multiplied to get rid of our fractions. So multiplying by a coefficient doesn't change the equation. It just multiplies it. So adding or subtracting the two equations produces equivalent linear systems. We can use this property to solve by elimination. All right, the idea of elimination is that we need to have a coefficient for either x's or y's that is identical. It needs to be the same number, okay? And then we can add or subtract the two equations and solve. So, I'm going to solve for x here, meaning I'm going to get the coefficients of x to be equal. For that to happen, I need to have a common multiple of 2 and 3. So I'm going to multiply this entire first equation by 3. So I'm going to get 6x plus 21y equals 72. To our second equation, to get x to be 6, I need to multiply by 2. So 6x minus 4y equals negative 8. Now what we're going to do is we are going to subtract the two equations to cancel our x's. So 6x take away 6x will be 0x. So we're just doing our vertical addition or subtraction statement here. So we had 6x take away 6x, we're left with 0x. 21y take away negative 4y. Remember, subtracting a negative is like adding. So we're going to get plus 25y equals 72 take away negative 8 is like adding 8. So we get 80. All right. So we're left with 25y equals 80. Now that we've eliminated one of our variables by subtracting, we can also add. I'll show you an example of that later on. We have been left with only one variable and we can finish to solve for y. So divide both sides by 25. I get that y is equal to 80 over 25 and reducing that to 16 over 5. Now that we've solved for one variable, it becomes the exact same. Sub into one of our first equations. Again, we may have made an error in multiplying this through. And this is a nice equation. There's no fractions, so I'm not worried about my math here. I'm going to use my first equation, not my multiplied one, just to make sure that if I've made an error in multiplying here, I don't continue it. So 2x plus 7y equals 24 is what I'm going to sub into. If you start to sub into something here maybe, and you get really, really crazy numbers, that might be an indication that you've done something wrong. So I would finish that up, check my work, and then remember that maybe I've made a mistake in this first step, just in multiplying my equations. So double check that work every time. All right, subbing in to solve for x. So 2x plus 7 times y, oopsie, we need the 7 out front, 16 over 5 is equal to 24. 2x plus 112 over 5 is equal to 24. Now I can continue and I can subtract 112 over 5 from both sides, and we're going to work with some fractions, or I can use that idea that I can multiply this whole thing by 5 to get rid of the fraction to start. So I'll be left with 10x plus 112 is equal to 120. And that makes a nice number to work with. Now I can subtract 112 from both sides, and I'll be left with 10x is equal to 8. Divide both sides by 10, x is equal to 4 over 5. Now to check our work, we can sub into our last equation there. So 3 times x, which is 4 over 5, minus 2 and 16 over 5 equals -4. Again, I'm subbing into my original, just so that if I've made an error, it doesn't continue. 3 times 4 is 12 over 5 minus 32 over 5 is equal to -4. 12 take away 32 is -20 over 5, which equals -4. And -20 divided by 5 is -4. So we've done this correctly. All right, use elimination to solve this linear system. This looks gross already because we've got fractions. So you can either multiply your fractions out or work with fractions. It's really up to you. Let's try multiplying our fractions out. So I'm going to start by multiplying this first equation here by 4. So that cancels out my 3 over 4. I'm left with 3x minus 4y equals 8. And I'm going to multiply my second equation by 8. So I'm left with x plus 2y equals 16. All right. So I'm going to make my y terms equal this time, actually. What I need to do is I need to multiply my second equation by 2 to get to 4. So I'm just going to write them both out again. I'm going to be left with 3x minus 4y equals 8 from my first equation, just so I have my equations stacked for adding or subtracting here. And I'm going to have 2x plus 4y equals 32. Now, this looks different because I'm not going to subtract. We have a -4 and a +4. So to get those to cancel, I need to add. If we add those two, I get 3x plus 2x is 5x. -4y, plus 4y is 0y. And 8 plus 32 is 40. So I'm left with 5x equals 40. Divide both sides by 5. I get that x equals 8. Excellent. Now I can sub this into my original equations, which I usually recommend because maybe we've made an error in multiplying. However, our original equations have fractions and that can get complex. So your call here. If you trust your work in multiplying, go ahead and use one with whole coefficients. If you're not sure, I know that fractions can be tricky, but it's always best to sub back into our original. Okay, so I'll sub back into our original just to show you. So 3 over 4 times x, which is 8, minus y equals 2. 3 times 8 is 24 over 4. Excellent. We're going to be able to reduce that to 6. Solving for y, subtract 6 from both sides. I get that -y equals -4. I cannot solve for negative y, so I either need to multiply or divide by negative 1. Doesn't matter, it's the same thing. Just to get rid of this negative, we're left with y equals 4. And to check our work, we can sub into our other equation. I'm going to again show you that we can work with fractions. It's maybe just a little bit more work sometimes. In this case, we're actually going to luck out, it seems. So 1 times 8 is 8, still over 8. 1 times 4 is 4, still over 4, which is 2. 8 divided by 8 is 1. 4 divided by 4 is 1. So 2 equals 2. This works. All right, solve this linear system. When it says solve, it doesn't matter. So I haven't said solve by elimination or solve by substitution. So you get to pick whatever method works for you. I'm going to continue with our elimination method here, just because that's what we're working on. But if you would prefer to substitute, go for it. All right, I can see that 3 and 9 for my x values are closely related. If I multiply my first equation by 3, I'm going to get 9x plus 27y equals 15. And I'm just going to copy my same equation for the second one, because if I subtract my two equations, I'm going to cancel my 9x's. So these cancel. 27 take away negative 6 is like adding, so I get 33y. 15 take away negative 7 is like adding, and I get 22. Divide both sides by 33. Get that y is equal to 22 over 33, which if we divide both top and bottom by 11, we get 2/3. All right, let's sub back into our first equation as is and solve for x. So 3x plus 18 over 3 equals 5. 18 over 3 is actually 6. So 3x plus 6 equals 5. Take away 6 from both sides. Get that 3x is equal to negative 1. Divide by 3. X equals negative 1/3. And last but not least, we can check our work by subbing into our second equation. So 9 times x, which is negative 1/3, minus 6 times y, which is 2/3, equals negative 7. Negative 9 over 3 minus 12 over 3 equals negative 7. I get negative 3 minus 4 equals negative 7. Negative 7 equals negative 7. We did it right. So when given a linear system, how can you tell if you should use substitution or elimination? It doesn't matter. Pick whichever suits you if it isn't specified in the question. Do what's easier. Do what's more comfortable. Do what is going to help you get the answer correct.